Hi everyone, I welcome you to this video. So in this video, I'll be just going through the questions that you had from your test. I'll try to do some few questions with you that assume that maybe they will need further explanation, but I'll just give you the rest of the questions for you to go through them at your own time now and look um, on how you could have approached it, okay, if you didn't answer them well in the test. And if ever I didn't cover some of the questions you had trouble with, okay, or you're struggling with, then make sure to tell me about it. Then I'll have to tell you the right approach for the question if you had challenges with it, okay? So we had these questions, okay? Then I think that we had algebra parts and we had also the calculus part. So with algebra, I'm not gonna discuss much. Okay, um, I think it was not as so hard. If you have also any challenges, please make sure to note that. Well, I'll just highlight just few things that I feel maybe they're necessary to highlight. Um, let's say for this part, you are supposed to put the square root on both sides and have negative 3 minus the square root of 3. Okay, and you're gonna have the another bracket where you have x to the power of 3 plus the square root of 3. Okay, so here remember that when you are factorizing a difference, okay, um it's more like you have the square root of this part and the square root of that part, so you can still simplify it as much as we don't have two perfect squares on the both side, but x to the power of 6 is a perfect square because it's like x to the power of 3 times to the all raised to the power of 2. So if you put a square root of this, you get s to the power of 3. Okay, so you would have simplified this in that manner. For number 3, I think you know that you need to find the first linear factor, okay, which you're going to divide then simplify until you find all the linear factors. And we talked about this in class, that to find the right or to look for the right values or that you should choose from to determine the the first values to substitute that will give 0 here, or the roots, you need to consider the coefficient of the leading coefficient here and the constant term. Okay, you need to consider the two constants. I said to you, you must ask yourself of what are the factors of 4, and factors of 4 is 4, and we have 2 and 1. Okay, and factors of 1 is just 1. Okay, and I told you that to find the all possible uh, values that could be the roots of this equation, which means when you substitute them, they'll give you 0. They'll give you 0. You must take now a fraction, or you must divide now each of this value with over this you must divide this value by this value, okay, which means you divide the factors of the constant term divided by the factors of the leading coefficient, okay. And if you divide all of these terms divided by 1, or you can see that you're still gonna have them coming back because everything divided by 1 is just itself, okay. So we can agree that these are the possible, okay, values that could be linear factors. So your duty is to now test from 1. Test if you substitute 1 in the equation, are you getting 0? So to the first constant value that you're going to substitute there and you're getting 0, that means it's your first linear factor to consider. So you're going to say that value minus, I'll call it b. Then you start to divide this equation by this so that you simplify your equation until you find all linear factors. Okay, we discussed about this in class, so I'm not gonna go through it a lot about it. Okay, so I'm not gonna talk a lot about it. So then, um, Yes, this one you must have a way to simplify it. I'm not going to do it here unless you have any challenges. I think it's straightforward. Then here you're calculating the general solutions. We talk about this, that you can use core functions to change either of the two trig functions, okay, to either 90 minus the angle, okay, so that you can easily solve now the general solution. Then here, if you recall, this is a form. Remember the time when we talk about how to use polar coordinates to solve trigonometric equations. So this is a form where you are like having a cos of theta plus b sine of theta equals to c. So if you recall this general equation we talk about how to simplify, okay, how to solve, I mean, the general solutions of this type of an equation. So please recall that. If you remember, we talk about having compare with this term where you have r cos then alpha theta, okay, where you have to compare these parts with these parts, okay. So please recall all of that to be able to solve this part, okay. General solutions for this part, okay, I think we can maybe try to look on that together. So I'll just take the same equation that we had before. So it was cos, sorry, put on a pen. So it was cos of d of 2 theta minus 7 cos of theta minus 3 equals to 0, okay. And in this equation, asked here to find the solutions in the domain between 0 and 2 pi, okay, which means the solution will strictly be between these two. It cannot be a general solution, okay. So it will strictly be between the two boundaries between 0 and 2 pi. So your solution should lie between the two, or either be equal to the two, 0 and 2 pi. So to solve this, obviously we need to now simplify this equation, okay. um if you see this, you'll recall that cos 2 theta can be simplified using the identities that you learned, that it's the same thing as 2 cos squared theta, okay, minus 1. So I just change this using identity. Then if you put back that, you'll have this equation coming back in this way. So you have to simplify this equation. Remember, our goal is to find the general solution. So we are trying to write it into a form of a quadratic form, okay. Then you're gonna have this. If you simplify, cos of theta minus 4, okay. Then from this, you'll have to now simplify this or factorize it, okay, to two brackets. And I told you that if you are confused about using cos, you can just treat cos as x, and you just use the same way of how you have factorized quadratic forms. So if you simplify this, you're gonna have 2 cos theta plus 1, and you're gonna have another bracket of cos theta minus 4, all equals to 0, okay. And this will result you to have two equations forming. The first one is going to be cos theta equals to negative 1 over 2, okay. And the other part will be cos theta equals to 4. So let's start with this part. This part, it has no solution. Why? Because there's no way that we can have our cos theta function having the y value equals to 4, okay, because the maximum value is 1, the amplitude is 1 of this function, okay. So we can never have it equals to 4. So here we have no solution for this one. We're not going to proceed on this one. then we can solve this one. But remember now, if you solve this, you're not going to solve it as if you're solving the general solution, because we are told the restriction that you have solution between 2 pi, okay? Which means here you need to understand what is happening here. We have cos negative, okay? And cos is negative in the second quadrant and the third quadrant, okay? Which means our two solutions possible here. We're going to have theta for the pi, and we need to find the reference angle here together. So the reference angle here is pi over 3, okay? If you solve this using the special angle triangles, you'll find that the reference angle here is pi over 3, okay? Then you have two solutions. For the second quadrant, you're gonna say pi minus pi over 3, okay, which is equals to 2 pi over 3. And another option of theta here would be pi plus for the fourth quadrant, right? Pi over 3, and which that's gonna give you 4 pi over 3, okay? So this will be the two solutions, and if you check the two solutions, that actually in a right domain that we're supposed to give solutions to, okay? So that's how you will answer this one. So we talk about this, please recall it back, okay? I'm not gonna do it here. We discussed the solutions of this one. If you have any queries, please uh, mention it, okay? And recall this, I hope this was clear. This is actually a cos, okay? A cos of pi over 3. I mean square root of 3 over 2, okay? So this is a cos. I hope it's clear. So I will have to move forward then from this. So to proceed, we'll remember that we have this other part, okay? So I just have one thing to highlight here. I think you are very much familiar with this type of questions. I'm not gonna do much of them, but what I'll advise is that here, try to let this part to be equals to A, and use a Dovenick diagram to solve them, okay? Which means you're gonna have a diagram describing these parts. So if you let arctan of square root of 3 be equals to A, which means tan of A would be now square root of 3, okay? Same thing for this one. If you solve, you're gonna have sine B equals to negative 1 over 3. Then you draw the diagrams, and those diagrams will help you to simplify uh, this, okay? So when after having this, you'll know that the cos of A plus B, and you'll expand this using the compound angled identities, okay? um then you'll be able to simplify it further. So please recall to this type of equations to solve, okay? Then this one, remember, these are the sketches, okay, for the polar curves. So please also um try to sketch them, then tell me if you're having any issues. So one thing that you're gonna do now, you're gonna move to the calculus part. So for calculus, these are basically the questions that you are having to that you do in class, okay? So I'll expect you to be able to find it easy to solve this one. This one is on the study guide, okay, the book that you have for calculus. Please check it. These two, they're just on the notes book, okay? Then uh you remember how to solve the absolute values. Yeah, most of the solutions here, it's not gonna be hard to solve them. So please recall that. So I'm just gonna discuss one thing here, which is here. So it said write r and theta in terms of a and s, okay? So you must recall that a is an area, okay, which is half r squared theta, Okay, and if you also recall, you'll know that if s, which is the arc length, is actually r theta, so you can actually use this equation to simplify. Okay, so to do that, you can say a is equal to 1 over 2, and simplify this and make it r and times r. Okay, and you're gonna have this, which is s, so you're gonna have a equals to 1 over 2 r, then s. So from this, you can then easily solve for r in terms of a, which is the area and the arc length, right? And we agree that you're gonna have 2 times the area over arc length. So that's how you're gonna do it for the radius r. Then now to solve for the theta, you're gonna normally just use the equation for arc length and use the solution we got here to substitute or to replace r. So you're gonna have 2a over s theta, and you multiply by s on both sides and divide by 2a. You're gonna have now theta being equals to s squared over 2a. So this would be the two solutions describing r and theta in terms of a and s. For here, just apply the knowledge that you have about the logs and exponents. Okay, you know this is the exponent, so this gives you s squared equals to 81. This is a number, same thing you have to do here, and you solve for x, so nothing much. So we proceed with to the rest of the questions. So we have this part. Okay, I think it's the second part of the calculus section. Okay, introduction to differentiation, and you remember that the first question is asking about first principles, and I think you figured that out. Then we have this part I want to discuss shortly with you. So they're asking you, they're giving you an expression, okay, where h is the height and t is the time in seconds, okay, and you're asked to find the differentiation, okay, the first derivative of the equation. And I don't think that should be something hard to do. Okay, so let me give you a hint. So here you're just asking to, you're asked to differentiate this, and your dh over dt, it will be you differentiating this equation in terms of t. Okay, and you'll have your solution as negative 10t plus 20. That is a constant, so it's going to become 0. So that should be your equation. And the second part is asking us to find what is the maximum height if the equation this represents the vertical projectile motion of an object drawn upward. So they're saying that if this equation was representing an equation of a projectile, okay, of an object thrown, okay, upward, we know by projectile motion it will reach a maximum point there. Okay, and we know that this is the maximum height we are talking about. Okay, from here to there. Okay, it's a maximum height, so this is a position where the maximum height is found. So for us to find what is the maximum height, which is h here, we need to find at what time is that maximum. Okay, but for us to find that, we need to understand what information about our maximum point or our maximum height. What we know about the maximum height is that the change here, if you draw a tangent here, it's going to be a horizontal tangent at this point, which means the change of h with time here is 0. You know, for the turning points, okay, if you draw a tangent, we're having there the horizontal tangent, which means the differentiation there, or the derivative of the function, is equals to 0. Okay, so we can do that. So we can take this equation which we have and equate it to 0. Okay, so find the time at which we have the maximum. Okay, and if you do that equal to 0, you will find out that your time t is actually 2 seconds. Okay, it's actually 2 seconds. Then when you substitute that back to the equation of t, substitute 2, you'll find that to the main equation, you find that we're gonna get about 22 meters. Okay, so yeah, that is the approach of the, so please take note of that. Then let's proceed. If we proceed, here you have derivatives. So recall how to do the derivatives. It will be easier if you write this now with the negative exponent, so that you can easily differentiate. Okay, and this part, I want to comment on this question. I think for this one you should be able to solve it easily. For this part, note that this log are constants. Okay, so the log of 10 base 10 to the power of 3 is a constant. Log of base 10 to the power of 2 is a constant. So if you differentiate a constant, you know it's equals to 0. And here you are differentiating in respect to y, and here you're having this part which is a constant going in here with along with y. Okay, so if you differentiate this, the answer for the whole thing here is going to be log of base 10 to the power of t, because if it's, you have the constant as the solution, and this will become 0. So that will be the solution. Okay, um let's proceed. Okay, I'll just have to discuss these questions for number 4. Okay, and I think that would be it. So let's go through the questions. So for the first, you are given to find the limit of theta, um yep, of theta over sine theta. Okay, so that is what a is. So find the limits as theta approaches 0 for theta over sine theta. Okay, so for this case, you need to recall the identities we talk about that involve sine theta with theta and also cos theta with theta. Please recall them because they're going to be helpful when you're solving such problems. Okay, so in this case, you have to change this to be in a form that is familiar to you, and if you change it, this would be the same as limit of theta approaches 0 of sine theta over theta to the power of -1, which is the same thing as that one. Okay, so I've changed it to the form that is familiar. So now it's going to be easy for me to operate the limits of sine theta over theta, because I know from the identities that we talk about it equals to 1. Okay, so this is the same as 1, also the power of -1, which is basically just 1. Okay, so that is how we're gonna solve this one. So for B, we gonna use the similar approach. Okay, so there we are given that to find the limits as theta approaches 0 for theta times cot, right? Cot theta. Okay, so the simplest way we can ever approach this is to simplify this into cos and sine. Okay, and you're gonna have that, and you're gonna have theta cos of theta over sine of theta. Okay, then with this part we can now try to change this to a form that is familiar to us. Okay, and you're gonna limit of theta approaches 0, and we're gonna now take this denominator and try to compare with it, or try to relate it with theta, because we have an identity that is familiar to us when it comes to that. And we're gonna have theta. Okay, after this we'll try to apply now the exponent of a negative. Okay, so if you apply the exponent of a negative, we agree that this will have to change. Okay, this will have to change, meaning that it should be more like we have theta over, I mean sine theta over theta, uh, times 1 over cos. Okay, times 1 over, so whatever that was in the numerator, it will become now in the denominator. So when we now evaluate this, we know that we know the limits as theta, I mean approaches 0, of this part is equals to 1. Okay, so we know that now we are left to simplify here is actually this part. So this one is part is 1, and this part is 1 over cos theta to the negative 1. And with this left, we know that if we operate this now using the power of negative, it's still the same thing as limit of theta approaches 0 of cos theta. Okay, if we solve this back. Okay, then if now we look at this expression, we can see that we can substitute our theta now, because it's not going to give any undefined, and that would give us a cos of theta equals to 0, which is equals to 1. So that would be a solution here. Okay, the last part that we need to discuss on the calculus. So we have the following question, which is this one. We are asked to find the equation of a tangent to the curve, and you're given the curve here. Okay, given the curve, and we are given also the domain for which it exists in, and we are told that the tangent, okay, that is drawn is at the point where x is pi over 3. Okay, so one thing that you need to find now, to know the gradient, you need to find out the gradient of the equation of a tangent. Okay, and to find the equation of the gradient of the equation of the equation of the tangent, you need to differentiate your first equation. Okay, so you're gonna have dy over dx. Okay, and if you differentiate it, you find 1 here. If you differentiate x, and if you differentiate that, you're gonna have plus 2 cos x. Okay, if you differentiate 2 sine theta. Okay, then with this, you know that the x value is actually where x sorry, um this happens where x is equals to pi over 3. So you substitute pi over 3 to the equation of dy over dx, and you'll find that your answer is 2. Okay, you find that your answer is 2. So that will be the gradient of your equation. Okay, and now after finding the gradient, which means from your equation you have the gradient, which is 2 and x. Okay, you are left with to find the value of c. Okay, you're left with to find the value of c. So to find the value of c, you need to substitute this x, okay, to the original equation. And when you substitute pi over 3 to the original equation, you find an answer to pi over 3 plus square root of 3. Okay, so you don't have to simplify that. Fine, calculator, and you'll have the solution here to be pi over 3 plus square root of 3 for the equation of a tangent. Okay, so okay, that's it. Then this question, I'm not gonna do it, I'm gonna skip it. I think we talked a lot about this. So what you need to do here, you need to find the turning points, okay, for the equation. Okay, you need to differentiate and equate to 0 and get the turning points uh here. Then after doing that, you need to use now the first derivative test. You remember we said you need to find the x values that are that comes before the critical point and substitute now to the equation of the first derivative. If you're getting a positive answer, it means the gradient is positive. Okay, and you now substitute another value that is above the critical point, and if you're getting a negative answer, it means the gradient is negative, and that should determine that value, that critical point is actually a maximum, or a local maximum. Okay, so for a local maximum, it starts with the positive gradient and ends with the negative gradient, whereas the local minimum starts with uh, the negative gradient and ends with the positive gradient. For the second derivative test, we talk about this. We said that for the local maximum, okay, for the local maximum, the derivative is negative. For the local minimum, um, the second derivative is positive. So please try to evaluate that and see the points that are true to be local maximum and minimum in this curve. Okay, um, the last thing to discuss now is number 7. So for number 7, you are told that a sector has an area of 1 centimeter squared. And if you remember the sketch of a sector, something that looks like this, okay, where we have an angle theta inside. This part is our r, okay, this part, okay, is our r, and this is our arc length, which is r theta. Okay, so they are saying that find r and theta, okay, that will minimize the perimeter. Okay, which means find the r and theta that will give the minimum possible perimeter of the sector. Okay, so for you to answer this question, you should not forget of how you answer this type of questions, okay, where you are understanding the local maximum and local minimum. So here it means like we are trying to find now the local minimum of the perimeter. Okay, but now we're trying to evaluate it in terms of r, okay, and in terms of theta. Okay, so to do that, we need to define the perimeter of a sector. Okay, so the perimeter of a sector, I'll call it P, is equals to 2r. The 2r, it means we are adding this r on this side plus this r plus s. Okay, the perimeter, it means, you remember, it's an outer length of uh the certain shape that you have. So it's 2r plus an arc length. Okay, and if you simplify this, you know that uh our arc length actually is r. Okay, so what we're gonna do here, since we're gonna need to differentiate the equation, we can't have two variables. Okay, we have theta changing, okay, and you have r changing, so we can't have two variables in the expression. So let us change this equation such that we have one variable. So we're gonna change theta to be in terms of r. Okay, so the one thing that we know is that our area is equals to 1. So from this equation, a equals to squared theta, we know a is equals to 1. Okay, and if you solve for theta here, you understand that theta is actually 2 over r squared. Okay, so we're gonna take that and substitute it back in this equation. So you're gonna have P. Now P is gonna be in terms of R only. Okay, it's a function of R because so it's gonna be 2R plus R, and I'm substituting there. It's gonna be 2 over R squared. Okay, and if this equation simplifies, you're gonna see that this equals to um 2R plus 2R to the power of negative 1. Okay, because this would cancel the power there. Okay, so um from this point now we have defined an equation of a parameter in terms of R only. So what we're gonna do now, since we have the equation here, we're gonna differentiate the equation. And remember, when we differentiate an equation, we are trying to find the critical values. Okay, or should I say the the critical points. Okay, for the equation for which we can either have a minimum or a maximum. Okay, R for the expression. Okay, so I'm gonna differentiate my R first derivative. Okay, and if I differentiate it in terms of R, I'm gonna have there 2 plus what, it's not gonna be plus, it's gonna be negative because the power there. Okay, it's gonna be negative 2 R to the power of negative 2. Okay, then what I'm gonna do is that I'm gonna equate all of this to 0 so that I can find my critical values. So if I solve there for R, okay, I'm gonna end up having an equation like this, equals to 1. Okay, then if I try to solve for R here, I'll have my R equals to 1. Okay, so I'm just gonna call it 1 centimeter. Okay, solve this equation. So this is my critical point in some sort. For here, it's my critical radius. Okay, so I have to test if my this radius is giving me a minimum or is it giving me a maximum. Okay, so to test that, we know that there is a way to do that without struggles. We can just do the second derivative test. So I'm going to derive this equation for the second time, which means the second derivative. Okay, and if I do that, I get negative 4 R to the power of negative 3. And for that, I'll substitute now I'll let my R to be equals to 1. Now I'll substitute my R equals to 1, and if I get the answer that is positive, which means I'm having what? I'm having a minimum. If I'm getting answer that is negative, it means I'm having a maximum. So if I substitute 1 there, okay, I'm gonna get my answer to be this part will my answer will become negative 4. Okay, and as am I getting my answer like this, it means I have my parameter or for the second derivative. Okay, I will have my parameter to be for the second derivative, it's going to be less than 0, negative. Okay, so this tells us something about 1. Okay, just please take a note of something. I made a mistake here. Please recall that here the answer is supposed to be positive. I see that something is not making sense. Okay, remember, if you multiply this to that, it's going to be positive. Okay, so we are having our answer is positive, which means our second derivative is positive. Okay, not negative. Sorry for that. Okay, And we know that if our second derivative is positive, it means it is a local minimum, right? We know that it is a local minimum. So we are having a local minimum. In this case, we are having a minimum radius. Okay, minimum. Okay, so the we have now left with one thing to conclude. So we will say that therefore, therefore, the perimeter is minimum. Sorry, the perimeter is minimum when r is equals to 1. Okay, then the question is going to ask us, then if r is equals to 1, what will be the value of theta? Okay, so you'll recall to the equation we described before. Since we said a is equals to over 2 r squared theta, and we know a is equals to 1. Okay, when you solve for theta here, we saw that theta is equals to 2 over r squared. Okay, so since now we know that the minimum r is 1, so when you substitute here, we're going to have theta equals to 2 over 1 squared, which means theta is equals to 2 for where, or in radians, remember, in radians, for where the minimum radius is 1. So we know we're going to conclude that perimeter is minimum when r is equals to 1 centimeter and theta is equals to 2 radians. Okay, so that will be our conclusion. Okay, to close up with. Okay, we have our minimum our minimum radius equals to 1 and our theta equals to 2 radians. So make sure to this type of questions, okay, where they talk about the maxima and the minima, you try to use the same understanding you use when you're doing local minimum and local maximum of the curves. Okay, it's always the same understanding. Okay, so that is what I wanted to share with you with this video. Cheers.